All right, welcome to the conclusion of the COVID-19 material and the conclusion of the course. How sad. I think I can hear some of your little lips quivering and tears rolling down your sad faces. I think I can hear that through this microphone. Maybe I'm just hearing my kids scream in the background. They're definitely sad. But anyway, so in this video, we'll conclude the COVID-19 data and conclude the course, and we're going to just pick up right where we left off. So the goal of this video is to get plots, so to get pictures of COVID-19 cases in Italy. So Italy, of course, being one of the hardest hit countries. Let's see if we can visualize the outbreak there. So if you care about Italy, the first thing you should do is slice country region by Italy. So I'm going to do that slicing and then show you the resulting data frame. So if all I do is pluck off Italy, in that data set, it turns out Italy was not stratified by province or state. For whatever reason, they decided not to keep track of the province data inside of Italy. So there's just one row for Italy, and here's the data for Italy, 000 for a while, and then, oh my goodness, like look at this, right? Again, I'm going through April 12th. They have more than 150,000 cases in Italy, April 12th. Okay, so if you now want to do some plotting, our challenge, as I said last time, is basically starting right here. I want to kind of like chop here and make a day column or a date column where these guys are in a column and a case column where these guys are in a column so that we can just plug straight into our matplotlib commands from the baby name data. So if I'm going to do that, the first thing to point out is that this province or state column is unnecessary here, so I'm going to drop it. Okay, so it's the same exact data frame except that province column is missing. Okay, now before I move on, notice I've sliced from the original data frame, which was called data, and in that data frame, Italy was row 137, and so there's still 137 there that we can use for location purposes. Even though there's only one row here, this one row still counts as row 137. Now, of course, there are commands you can use to change that 137 to, say, a 0 or a 1 if you want to, but we don't really need to, but you can do that if you want. Okay, so here's sort of like the meat of this material. We're going to create a data frame of the Italian data that we can use for the purposes of plotting. So what this does is it creates a data frame with a day column and a column with the cumulative number of cases on that day. Okay, so it's just going to take, basically going to start right here and turn these dates into a column called day and take these case numbers into a column called num cases. So the first thing you can do, notice by the way, is you can get a list of columns like this in pandas. So you can just do list of data2. So this will be a list of the columns. So it'll be a list of columns. So it'll be like country/region and then 122.20, 123.20, and so on. Now I'm going to create a new data frame called data Italy, and it's going to have a column called day and a column called num cases. So this is reaching back all the way to the beginning of this material when you can create a data frame by hand. This is how we did it, right? You can control, if you want to, from scratch, the column names and then the entries if you want to. So notice up here, January 22nd is the first day, so I'm including that as the first day, and the initial number of cases was 0. So basically I'm creating a data frame where this is like my first entry in my first column. This is my first entry in my second column. That's what this data Italy is now. That's just sort of a start point, you know. So from here, I'd like to just keep doing that, keep creating a day paired with a number of cases, day paired with number of cases. I'd like to keep doing that all the way through the end of this data frame here. How do I do that? I do it with a for loop, and I'm going to do it by iterating through the columns. So for I in columns, now, I don't care about the country/region column. I don't care about that word Italy right there right now. I also don't care about the column labeled 122.20 because I've already accounted for it. I've already thrown it in there. So what I need to do is start with this column right here, this 123.20, and then go all the way through the end. That's why I have this not equal, not equal. Okay, so now what am I going to do? I'm going to create a data frame called day, and then just here's the column name I'm at now. So there's the date now. So I started on 122. This is going to be 123, then 124, and so on. And then what's the number of cases going to be? To figure out the number of cases, I have to go inside this data frame up here, and I've called it data 2. I have to go inside data 2 at row number, and the row number again is 137. Well, row number is 137, so at row 137 and whatever column I'm at. Okay, so just to clarify here, right? I is just whatever date I'm talking about. So I is like that value, that value, that value, that value, that value, and so on, right? So if you want the number beneath it, you have to tell Python row, which is 137, and column, which is whatever the date is. And then just append that. So I'm just going like, I'll create a data frame called that append, called that append, that append. And I'll get the Italian data, but I'll get it like this. So check this out, right? A day column, a number of cases column. So 0000, and then they got their first couple of cases on January 31st, and so on, all the way down to April 12th. So there are 82 total rows because we start at row 0, and we go up through day 81. So there are 82 total days in this data frame. So now, why would you do this? Why do you create this? Again, the reason is because what you want to do is get a plot of the number of cases over time. And once you have a data frame like this, you can now do that using the commands from last time. So let me show you that. Where is it? Okay, you can plot Italian data, day is the independent variable, the x-axis variable, and the number of cases is on the vertical axis. And check this out. Okay, there is a plot of the number of cases, total number of cases over time. It's this nice sort of exponential looking curve, isn't it? You know. So again, I'm on April 12th. My data goes through April 12th. So by the time you run this, perhaps this curve is like flattened out or something. Maybe it's topped out. Who knows? But anyway, here's a picture of the Italian case data. And what's so nice about being able to get a picture like this instead of staring at numbers in a spreadsheet, you can start to see, even with my data here, you can start to see that it looks like it's now trending towards peaking out and then falling, right? So the exponential part is like right here. There appears to be like an inflection point right there. For those of you who like that language, an inflection point where the rate of growth seems to be slowing down. And you can just sort of see that. Now, of course, this x-axis is just a jumbled mess down here. So you can either just accept this jumbled mess down here or not, but you see it's plotted the name of each tick mark. So there's 122, 123, 124, and so on. So what a mess this is to look at. If you want to just cover this up and ignore it, you can. If you want to clean up that data, you can do things like this. So I'm still going to plot the same thing. These two lines here just say, hey, don't plot anything on the x-axis. Don't label any of the x ticks. So this is an empty list here, which means, hey, like don't plot anything down there. And this is now no longer so bad to look at down here. You would just have to know it starts on January 22nd and goes through April 12th. But of course, it's the same picture. If you want to do things like label, say, the first and last ticks, there are ways to do that nicely. But notice here, I'm just going to create a list of tick marks. And the first entry in my list is the first day. And then notice what I do. There are 82 total days. I've accounted for the first day. So for 80 days, I'm just going to append emptiness to the list of tick marks. And then at the very end, I'll append the last day. So I have basically a first day, emptiness for 80 times, and then a last day. And then I put that list in here for the xtick labels command. And I will just plot a tick down here for 122, and then a tick over here for 412. So anyway, you don't have to do this if you don't want to, but it just bothers me that this is such a jumbled mess. There are various ways you can clean up that jumbled mess like these. There are other ways, of course, you can do it. But this is sort of like a nicer little picture here. I'll leave it to you if you want to figure out how to like plot every 10th tick or every 15th tick. That might look a little better. But anyway, here's a plot of the number of cases over time. Okay, so I want to finish this material and finish this video by talking about how do you get the number of new cases per day? How could you plot that? Because again, I've mentioned this several times, right? But this plot, you're watching the total number of cases cumulatively up to a given day. That's what this plot is. So the fact that you're at 40,000 right here, that does not mean that there were 40,000 new cases reported that day. That doesn't even mean there are 40,000 cases on that day if people are still sick. That just means that up to that day, there have been a total of 40,000 confirmed cases in the country total on any day. So this is a cumulative picture right here, right? Okay, so how would you plot though? How could you get a picture of the number of new cases on a given day? So how could you build a data frame that looks like this, okay, like this, but this column is not the number of total cases in the country over time, but just the number of new cases on that day. So like right here, this entry right here, this 2 means there are 2 total cases reported ever up to that date. However, those 2 cases have already been recorded on January 31st. So what's the number of new cases right here? The number of new cases is 0. There were no new cases reported on February 1st. So you'd like this number to be a 0. Same with that one, should be a 0. There were no new cases reported that day, so on and so on. But then on February 7th, there was a new case. So this 3 should be a 1 if you're tracking new cases. And then since these are all 3s, these should all be 0s now, no new cases. No new cases for a while. Somewhere in here, that 3 switches to a 4 or 5. So then how would you plot like a 1 or a 2? And then all the way down at the bottom, right, in moving from March 18th to March 19th, there were roughly like, what is that, 5,500 cases reported, new. So how could you right here have 5,500 instead of 41,000? How would you do that? Okay, let me just show you that, and then we'll be done. Where is this? Okay, so this code creates a data frame where each entry in the case column is the number of new cases on that day, in contrast to the previous data frame, which was cumulative. Okay, so now I'm going to get a list of rows, and the way you can do that is with this command. So dataitaly.index.values. That's how you get the list of rows of any data frame you feel like. Okay, so now I'm going to create a new data frame called data Italy new cases. So not total cases, but new cases. Again, though, I'm going to start it the same way with January 22nd as my first day. Number of new cases was 0 because there weren't any cases on that day. And now check out what I do. I march through the rows now. And I don't need to think about row 0 because I've already accounted for it. Right? So way back up here, row 0 is right here. There were no new cases that day. And I've already recorded that information. So I don't need to worry about I equals 0. So that's all this is saying for any other I. Okay, so check out what I build here. I'm going to build a new data frame called data that I'm going to append to the new cases data frame. Right? As of right now, the new cases data frame is pretty small. It's just got 1 row for January 22nd. Now, as I move through the rows, look at what I do. I create a day column like this. So basically, I just need the day to be the day corresponding to that row. So at row 1, tell me what day it was. At row 2, tell me what day it was. So back up here, row 1, the day was 123. Row 2, the day was 124, and so on. So that's how you record the day information. That's all that's saying. And now, how would you figure out the number of new cases? Let me show you this. Well, you got to figure out the number of new cases at row I, the row you currently care about, and subtract the number of cases at the previous day. So let me say that again, okay? So this right here, you're going inside the Italian cumulative data and just looking at the number of cases on a given day. If you want to know the number of new cases on that day, you have to take the total number of cases on day I, from row I, and subtract off the previous entry. So that's what's doing this. It's going to do like 135,586 minus 132,587, and that number goes right here. So whatever row you're at, you have to subtract what came previously in the number of cases column. So this is kind of hard to look at, but that's what's happening. So again, the day is just whatever the day was originally, day row I. The number of new cases, though, you have to take the number of cases now and subtract off the number of cases from the previous row. If I is the row number, you got to take 1 off of that. Then you just append. Okay, so let me just show you what this data frame is after I run it. So data Italy new cases. Okay, so new cases. Oh, there's 2 new cases here. But as I pointed out, on February 1st, there were no new cases. Right? There was, in the original data frame, there was a 2 followed by a 2 followed by a 2, right? No new cases for a while. And then down here at the end, see, these numbers are not in the 100,000s, right? These are in the thousands because it's just the difference between this day and the previous day. So that's how you can get just the number of new case information by setting up a little for loop like this. That's pretty nice. And now we have a data frame called data Italy new cases, where the columns are day and num new cases. So you can plot that. And again, I'm going to plot it with the x-axis cleaned up in this display a little bit. And there you go. There's a plot of the number of new cases by day. So this is sort of generally going up. And again, by the time you plot this, I don't know what it'll look like. Maybe it will have tapered off even more. But there's this clear upward trend until like, early March or something. And then things kind of turn around a little bit. One of the most interesting things about this is that notice this dip right here. So the number of new cases was going up. And then on one day, they reported 0 new cases. This is the kind of thing you'll see in these like fresh new data sets, right? Where people haven't like cleaned them properly yet. So presumably there was probably just some like issue of reporting right here, right? They just, for whatever reason, didn't report any new cases that day, but surely there were some, and there must have been an issue getting it into the spreadsheet or something. So anyway, you can see like little errors like that in these plots, right? It makes no sense to have no new cases right here, but then suddenly the next day, right? So who knows? Maybe like the testing operations just shut down for a day, and then suddenly you get this huge spike the next day because you're getting 2 days at once. Who knows? Anyway, here's the plot of number of new cases over time. You can see it starting to taper off. That's good news for Italy. Finally, I just wanted to point out real quick, in your homework, I'm going to ask you to deal with the United States. So, of course, you can deal with the United States in much the same way as you can Italy. However, the nice thing about Italy was that, way back up here, where was it? Italy, where are you? Okay. Italy was not broken down by state or province. There just was an Italy row. Now, that's not true of the United States. In this data frame, there's not just a United States row. There's a row for every single state. So there's actually like 51 United States rows. So how could you just get United States to be its own row? Check this out. So I'm not going to run this right now, but I call this data C for country. You can group by country region. And then if you do a dot sum right here, notice normally we'd give it a column name here, right? There'd be like a column, like whichever column you care about, you add up that column. If you don't include that column information, Python knows, oh, well, he's telling me to add stuff up within each country, right? So within each country, I'm supposed to add stuff up. So he must want me to add like everything up. Everything I can add, I should add within a country. So what that will do is if you do a dot sum like that, it'll go inside the original data frame. So way back up here, wherever the original one is, like here. And so like within Australia, say, grouping by country, within Australia, it'll take this column and just add up all the Australian entries to get you an Australian total for that day. And then it'll do it for the next day and the next day. It just knows to add up literally all the columns where it can add things up. So it'll just give you an Australian total for a given day. And it'll do that for any country. So in the homework, keep that in mind. If you want to deal with the United States, the first thing you should do is like form this data frame. Like a country by country data frame where you've grouped by country and now all the states are aggregated. So keep that in mind for the homework. Okay, well, we've reached the end of data analysis. Hopefully this is of use to you. I just love this. I love being able to plot these things. I myself am not a data analyst, so I don't get to do this that often. My own mathematical work doesn't really involve this kind of thing. My mathematical work involves the kind of Python we did before your second exam. So just sort of classical computer science stuff. I don't do much data crunching for my own work. The papers I publish doesn't really involve any graphs like this, any sort of data crunching. But this is really fun. It's fun to play around with, fun to look at. All right, so that's it.